You know that feeling when you are incredibly motivated, right? Like you're ready to build something amazing, your whole team has this great momentum, and then bam, you just hit a wall.
Oh, yeah. The universal developer experience. You go from full speed to just a complete dead stop.
Right. You submit an IT ticket for a new development environment, and suddenly you are staring down a 3 to 5 day wait.
If you're lucky. And you're just sitting there waiting for someone in another department to, manually provision your workspace.
And the absolute worst part is, when you finally get that environment a week later, it's almost guaranteed to be slightly different from the last one you asked for.
Oh, completely. It's
Yeah.
never quite right.
Exactly. Well, welcome to this custom-tailored deep dive. We are thrilled to have you here with us. If you are someone who loves to understand not just how the tech world is changing, but exactly why those changes matter, without drowning in all the unnecessary jargon, you are definitely in the right place.
Yeah, we're really going to get into it today.
Our mission today is to completely deconstruct that specific IT bottleneck. We're looking at how to just eliminate it entirely.
Specifically, we're looking at this really fascinating session abstract and a comprehensive slide deck. It's titled Deploying Power Platform and Azure Infrastructure as Code.
Right.
And this material comes from Raphael Pothen. He's a lead Power Platform reliability engineer at Manulife and also a Microsoft BizApps MVP.
And I have to say, his presentation is, it's basically a blueprint for a revolution in how we handle internal tech. We're going to explore how bringing infrastructure as code, or IAC as people call it, to the Power Platform can basically give developers total self-service control over their workspaces.
Yeah, which means no manual portal clicks and definitely no waiting days for IT.
Right. We are talking about automating the whole foundation for an internal developer platform. But to really understand why this is so necessary, we really have to look at the reality of manual provisioning at scale.
Yeah, because it's messy. When an organization relies on humans clicking around in an admin portal to set up environments, things inevitably break down.
Because humans make mistakes.
Exactly. For starters, portal clicks leave no reliable audit trail. You have no real peer review before a change is made to your infrastructure.
Right, so if an admin accidentally clicks the wrong toggle or forgets to check a box, nobody knows until something downstream just mysteriously stops working.
And good luck tracking down who clicked that box, which leads directly to a massive problem known as drift.
Right, drift.
Yeah, drift occurs when your actual living environment no longer matches your documentation, or what you assume is actually deployed.
Because people go in and make quick fixes, right, like a late-night patch.
Exactly. Over time, all these little manual tweaks accumulate, and eventually, you can no longer definitively prove what is actually running in production.
That sounds like a compliance nightmare.
It really is. Add to that the sheer bottleneck of the process itself. Because only a few admins have the actual security rights to make these portal changes, you have hundreds of developers just sitting there in a queue.
Waiting for their ticket to be answered.
Mm-hmm.
Which brings us to the real hero of our story today, infrastructure as code. The core idea here is that instead of manually clicking through a portal, you write a text file.
Right.
You just write out a file that describes exactly what you want your environment to look like, and then the system reads that code and builds it for you.
And Raphael's presentation highlights several key benefits to this approach. Because it is written code, it's version control.
Just like regular software.
Exactly like software source code. Every single change is reviewed, it's tracked, it's stored, and it's also perfectly repeatable.
Meaning no drift.
Right. If you put in the exact same text file, the system provisions the exact same environment every single time. This is really the foundation that actually makes self-service possible.
I actually like to think of this shift using a food analogy, if you'll indulge me.
Oh, I love a good food analogy. Go for it.
So imagine the difference between imperative and declarative systems. Manual provisioning, the old way we just talked about, is imperative. It's like walking into a busy restaurant kitchen and trying to micromanage the chef.
Oh, they would love that.
Right. You walk in and say, okay, take out 2 slices of bread, now open the mayonnaise, spread exactly 1 ounce of mayonnaise, now get the turkey. You have to give every single sequential instruction.
And if you forget one step or the chef gets distracted,
your sandwich is completely ruined. You get dry bread and a slab of turkey.
And if you need 50 sandwiches for your entire team, you have to repeat those microscopic instructions 50 times.
Exactly. It's exhausting. But infrastructure as code is declarative. It's like just handing a highly trained kitchen a ticket that says 1 turkey club.
You declare what you want the end result to be.
Yes, you declare the end state. You just trust that the system knows the underlying steps to build it perfectly, consistently, every single time.
You're defining that desired state and leaving the execution up to the system. And in this context, the kitchen, fulfilling the order, is a widely used tool called Terraform.
Okay, so let's unpack this a bit. Terraform is the engine making all of this happen, but if I'm a listener who hasn't spent my weekends reading Terraform documentation, what are the actual mechanisms at play here? Like, how does this actually apply to the Power Platform?
Well, the first core concept you need to know is the provider. Think of the provider as the specialized translator between Terraform and whatever platform you're trying to control.
Like an API wrapper.
Sort of, yeah. In our case, Terraform uses a provider like Microsoft Power Platform or the Azure provider to interact directly with Microsoft's APIs. It essentially teaches Terraform the specific language needed to talk to those systems.
So the provider is the connection. It makes the communication happen. Then I assume we have to define what we actually want built.
Right, and that is the resource. A resource is the physical infrastructure item you were declaring in your configuration files, which, by the way, end in .tf.
Okay, so a.tf file.
Yeah, a resource could be a brand new Power Platform environment. It could be a SQL database or even a security group. You tell Terraform, ensure this specific resource exists, and Terraform does all the heavy lifting to make reality match your code.
But wait, if I just have a static file saying build a database, how do I make these resources customizable? Going back to my analogy, if I hand over a ticket for a turkey club, how does the kitchen know I want it on rye bread instead of sourdough?
That's where you handle those specific requests using variables. And those are stored in a separate file altogether called a .tfrs file.
So .tf is the template, and .tfrs are the specific choices.
Exactly. Variables let you parameterize your configuration. You can use the exact same underlying logic to build the environment, but feed it different variables to change the name, the region, or the size of the database.
Okay, that makes total sense.
And Raphael makes a really brilliant point here in his slides. Mandating one specific variable's file per workspace is the absolute key to enabling developer self-service at scale.
We'll get into exactly how simple that .tfrs file is in a minute, because the source material really surprised me on that front. It's incredibly lean. But first, what is the actual process? Like, I've written my declarative text file. How does the system turn that into a real server?
There is a very strict four-step pipeline flow that executes every single deployment. It goes init, validate, plan, and apply.
Init, validate, plan, apply. Got it.
So init kicks things off by downloading those provider translators we talked about. Validate does a quick syntax check to ensure you haven't made any obvious typos in your code.
Okay, pretty standard. And plan. That sounds like a preview step.
It is, and it's arguably the most critical step of the whole process. Terraform doesn't just blindly push your code and hope for the best. During the plan phase, it compares your .tf file against what is currently running in reality.
Oh, so it checks its work before doing anything.
Exactly. It calculates the exact delta, what needs to be created, what needs to be updated, or what needs to be destroyed, and it shows you a detailed summary before any actual changes are made.
That's amazing.
Only after you review that plan do you run apply, which executes the API calls.
It's literally like checking the blueprint, measuring twice, and then cutting once.
I love that. Now, Raphael highlights another concept in his presentation that he calls non-negotiable for enterprise security, and that's OIDC, or OpenID Connect.
Yes, highly important.
I know this has to do with how Terraform authenticates, but why is this such a big deal? Why is it non-negotiable?
Well, historically, to let an automated pipeline build infrastructure, you had to give it an administrative password or a static API key.
Right, you had to bake the credentials into the system somehow.
Yeah, and storing those secrets in your code or in your deployment systems is incredibly dangerous. If a bad actor gets access to your repository, they instantly get the keys to your entire cloud environment.
Game over.
Exactly, game over. Plus, it creates this massive administrative nightmare of constantly having to rotate passwords before they expire.
So OIDC essentially removes the need for passwords entirely. It does. It uses temporary, cryptographically signed identity tokens. The pipeline basically raises its hand, proves its identity to Azure dynamically, and Azure issues a token that is only valid for a very short window, maybe an hour.
Oh, wow.
The pipeline does its job, and then the token just vanishes. There are no static secrets stored anywhere on a hard drive.
It's like giving a bouncer a temporary VIP wristband that chemically dissolves in an hour, rather than handing them the master key to the entire building.
That is a perfect way to describe
It
it.
just makes so much sense. Okay, there's one more Terraform concept we need to hit, and it's about memory. Why is separating the Terraform state so crucial?
Right, so state is literally Terraform's memory bank. When Terraform finishes building your environment, it records every single detail about what it built and how it maps to your code in a state file.
So it remembers what it did.
Yes, when you run your next plan, it references that state file to figure out what changed.
I see. So um, if you put all your environment's development, testing, production into one giant state file, you are creating a massive single point of failure.
A huge one. Keeping states separate ensures what engineers call a separate blast radius.
Blast radius. I like that term.
It's very descriptive.
Yeah.
If a developer makes a catastrophic mistake in their code and somehow corrupts the state file for their local development environment, the damage is physically contained to that specific file.
It doesn't spill over.
Right. It is impossible for that error to accidentally wipe out the company's production environment because production operates from a completely different memory bank. They are like watertight compartments on a ship.
Got it. So we've got the tools. We understand the kitchen, the translators, the dissolving wristbands, and the memory. How does a developer actually order the sandwich? Because if we tell a developer who just wants to write an app that they have to learn and write hundreds of lines of Terraform first, we haven't solved the bottleneck.
No, we definitely haven't.
We've just given them a new, extremely complicated chore.
And that's the beauty of the architecture Raphael outlines. The developer doesn't write the underlying infrastructure code at all. The platform engineering team has already built it as a series of highly tested, composable templates.
I was looking at the slides for this, and I genuinely marveled at the simplicity. For a developer to request a governed, secure, enterprise-ready workspace, they only have to fill out 4 simple variables in their .tfrs file.
Yep. 4 variables.
Just 4 lines.
They specify the workspace template, which might be, basic, simple, or enterprise, depending on what they need. They provide a name for the project. They pick a geographical location. And they provide a security group ID to designate who is actually allowed to access it.
4 lines of text. And those 4 lines trigger an incredibly sophisticated 3-layer architectural pattern. The slides describe it kind of like a stackable cake.
Yeah, the 3-layer cake.
What is actually happening at the base layer of this cake?
So the base layer is designated PTN workspace. This handles the actual template-driven environments. Depending on the template you chose, it might spin up just a dev and prod environment, or maybe a full pipeline of dev, staging, test, and prod.
Okay.
It automatically applies the environment group settings, ensuring corporate governance is attached from day one. So you don't end up with orphaned, unmanaged environments just floating around the company.
Okay, so the base layer gives us the environments themselves, but an environment on its own is basically just an empty box. What stops that box from being totally exposed to the public internet?
That brings us to the second layer, the network layer. It's called PTN Workspace VNet Extension. And this is pure enterprise security automatically applied.
This is the good stuff.
It provisions virtual networks. It sets up private DNS zones. Most importantly, it applies zero-trust network security groups. By default, this layer completely denies all internet traffic coming in or going out.
Wow. Wait, so it's locked down tight from the very moment it exists.
Completely airtight. Until you explicitly open a port, nothing gets in or out.
That is incredible. And the top layer?
Then we have the top layer of the cake, PTN Workspace ALM Engine. ALM stands for Application Lifecycle Management. This layer takes your new, secure environments and automatically sets up your deployment pipelines, it registers the environments, and it even creates a fresh GitHub repository for your team to store their actual software source code.
So let me get this straight. Instead of a developer getting an empty box and then spending like 3 days figuring out how to secure it, how to connect it to GitHub, how to set up testing pipelines, it's just done.
It's all done for you.
Those 4 variables triggered the entire stack. Now, what happens if, say, the ALM layer needs an update? Do we risk breaking the network layer underneath it?
No. And Raphael specifically notes that there is an anti-corruption layer built between these stacks. They are loosely coupled.
Meaning they communicate, but they aren't tangled together in a big knot.
Exactly. They consume outputs from each other. Like, the ALM layer needs to know the ID of the environment it's deploying to, but they maintain independent life cycles. If the platform team rolls out an update to the workspace template, it doesn't accidentally corrupt your ALM deployment pipelines.
I imagine this loose coupling is also what makes decommissioning a project so safe. Historically, cleaning up old environments is a nightmare. People are terrified to delete an old server because they don't know what hidden systems might be depending on it.
Oh, absolutely. But with this pattern, you simply change a single variable in your code. You just set the lifecycle state to inactive.
That's it. Just change it to inactive.
That's it. And this triggers a safe, automated decommission path. It archives the GitHub repository so you don't lose your history. It deactivates the deployment pipelines, cleans up the virtual network, and finally removes the environments.
It does all the cleanup for you.
And because every step goes through version control, you have a 100% complete audit trail from the very second the workspace was requested to the second it was dismantled.
It's brilliantly clean. So we did it. We solved the provisioning bottleneck. But wait, let's say I'm building a project and I need a very specific custom environment setting.
Here we go.
Right. Maybe I need a specialized database connection that the central platform team hasn't built into those base templates yet. I can't just change my 4 variables to get it right.
Right, and that is the eternal struggle of platform engineering. You build great standardized patterns, but a central platform team simply cannot scale infinitely.
They just don't have the headcount.
Exactly. Dozens of product teams across the company all have unique requirements and tight deadlines. Meanwhile, the Power Platform itself is constantly releasing new capabilities.
So the platform team just ends up with a massive backlog of custom feature requests anyway. The bottleneck just moved from manual portal clicking to manual code writing.
The backlog always wins. To solve this, Raphael proposes a really powerful shift in mindset called inner source.
Inner source. Okay, like
Yeah.
open source software, but kept entirely inside the walls of your company.
That is exactly it. The platform team stops acting as the guardian, who has to write and control every single line of infrastructure code. Instead, they become the enabler.
How so?
They open up their internal Terraform templates and invite any software engineer in the company to submit a code change to add the custom feature they need.
Okay, here's where the source material gets genuinely wild for me. Raphael doesn't just talk about human developers making these custom contributions. He introduces the role of AI coding agents.
Yes, this is where it gets really futuristic.
I mean, software engineers can now safely use tools like GitHub Copilot to write these Terraform extensions. A developer who mainly writes front-end web code doesn't have to suddenly become a Terraform expert over the weekend.
Right, they can just describe the database connection they need in plain English,
Yeah.
and the AI agent helps them write the required declarative configuration.
The slides show these built-in agents literally living right inside the code repository. They have their own folder designated GitHub agents.
It's like having robot colleagues.
It really is. There's an agent called Terraform Implementer, which actively drafts the infrastructure code, and another called Pre-Reviewer, which acts like a senior technical lead scrutinizing the code before a human even looks at it.
It allows the organization to move at just incredible speed. Teams aren't waiting for the central platform team to learn about a new database requirement. They're using AI to build their own custom infrastructure extensions on demand.
Okay, I have to push back here.
Okay, let's hear it.
We are letting front-end developers, A&D AI bots, write core infrastructure code that physically touches the company's network and security layers.
I know how it sounds.
How do we not accidentally open a massive security hole or, delete the entire company's production database? This sounds like a recipe for absolute chaos.
Well, you're right. If you just unleash AI on your enterprise infrastructure without guardrails, it will be complete chaos. But the architecture Raphael presents prevents that by relying on something called a shared constitution.
A shared constitution. Okay, how does a piece of software have a constitution?
Well, in the root directory of the repository, there is a master file called agentsest.md. This is a repository-level set of strict instructions.
Okay.
It dictates the coding standards, the specific Terraform naming conventions the company uses, the security rules, and absolute stop conditions.
And this document applies to everyone.
It is the literal rule book for human developers. But crucially, it serves as the prompt context for the AI agents.
Oh, I see.
The AI is forced to read agentsest.md before it writes a single line of code, ensuring it plays by the company's highly specific rules.
But, an AI can hallucinate, right? And a human developer might just ignore the markdown file because they are in a rush to get a feature out on a Friday afternoon.
Which is exactly why the Constitution is only the first layer of defense. Anytime a code change is submitted, whether by a human or an AI, a GitHub workflow called detect-and-dispatch.mll immediately kicks in.
This is the automated enforcer.
Yes, it detects exactly which paths in the code were altered, and it triggers an independent, automated validation pipeline. This is the real safety net.
And according to the slides, this isn't just a quick spell check. Every single contribution has to survive 5 brutal stages of validation.
No shortcuts allowed.
Walk us through them.
First, the code undergoes an AVM compliance check. AVM stands for Azure Verified Modules. This ensures the code isn't trying to invent some weird, custom Azure setup from scratch, but is instead using Microsoft's heavily tested, standardized architectural building blocks.
Okay, so it stops rogue designs.
Right. Second is a format check to ensure the code is clean and readable for future engineers.
Makes sense. Stage 3 is the Terraform init and validate process to catch syntax errors. But what about security? What if the AI hallucinated an open firewall rule?
That brings us to stage 4, which is a deep security scan using a specialized tool called Trivy.
Trivy.
Yeah. Trivy physically scans the code looking for pattern matches that indicate hard-coded secrets like API keys. It also cross-references the code against a massive database of known vulnerabilities and misconfigurations before the code ever gets near a deployment state.
So if a human or an AI tries to sneak a password into the code or accidentally exposes a port, Trivy flags it and kills the process.
Instantly, it does not pass. Finally, we have stage 5, Terraform test.
Which is different from plan.
Very different. This isn't just running a plan to see what might happen. It actually spins up real, ephemeral infrastructure to test against the configuration, ensuring the components will physically behave the way they're supposed to in reality.
Wow. That is an incredible gauntlet. But let's say an AI agent writes a piece of code that miraculously passes all 5 stages. It aligns with AVM, has no secrets, it works perfectly. It doesn't just automatically go live into production, does it?
No. And this brings us to the most crucial safeguard of the entire system, what we might call the golden rule. AI proposes, human approves.
AI proposes, human approves.
The AI agent is treated strictly as a contributor. It is never, ever given administrative rights. Every single pull request, no matter how flawlessly it passed the automated tests, requires a mandatory human review before it can be merged into the main codebase.
So the platform team still has the final say.
Always.
But instead of spending all week writing custom infrastructure code from scratch, they are simply reviewing and approving highly validated AI-assisted code.
Exactly. They've moved from being a restrictive bottleneck to an automated enabler. They've built a system that scales developer autonomy without sacrificing an ounce of security.
Let's pull all of this together. We started this deep dive talking about the agony of waiting a week for a development server that ends up configured wrong anyway.
The imperative nightmare.
Right. And we explored how infrastructure as code replaces that imperative manual mess with a clean, declarative system like ordering the perfect turkey club and trusting the Terraform kitchen to build it.
And we looked at the composable patterns, that 3-layer cake of workspace, network, and ALM that allow developers to trigger enterprise-grade setups with just 4 variables.
Just 4 lines of text. And then we tackled the scale problem. When the central team can't keep up with custom requests, you implement an inner source model. You let AI coding agents help developers write custom extensions, but you put them in a straitjacket of security.
A very tight straitjacket.
You guide them with an agentness.md constitution, and you force every single change through a ruthless 5-stage automated pipeline, followed by a mandatory human review.
If we connect this to the bigger picture, it really represents a massive cultural shift for IT. For decades, IT departments have had to act as gatekeepers because manual oversight was the absolute only way to maintain security.
Right, they had to say no to keep things safe.
But this architecture proves that you can automate the gates. You can build an internal developer platform that genuinely empowers teams to move at their own speed.
So what does this all mean for you, the listener? Because this isn't just a technical tutorial on Terraform. This is the blueprint for scaling any technical team. It's about how you give people autonomy without giving them the ability to accidentally burn the building down.
It's about working smarter, not harder.
But it also leaves me with a really provocative thought to end on. We set up this incredibly rigid system for the AI, right? It strictly follows the agents.md file. It reliably passes a 5-stage automated security gate because it doesn't get tired. It doesn't get impatient. The AI never complains about having to run the Trivy security scan.
It just follows the protocol every single time.
So it makes me wonder, as these systems evolve, are we approaching a future where an AI contributor is actually less of a security risk than a human developer?
Wow.
I mean, think about a human who might be running late on a Friday afternoon and tries to cut corners just to get a feature out the door. If the automated kitchen knows exactly how to make the perfect sandwich every time and follows every health code to the absolute letter, maybe we humans should just stay out of the kitchen.
That is a fascinating way to look at it.
Something to think about next time you are sitting there waiting on that IT ticket.
Thanks for joining us on this deep dive. We will catch you next time.